let's start talking about Aditya-L1 because that's what I'm picking up here on the front page, Varghese. Ladies and gentlemen, after Chandrayaan 3, now India is going to send its observatory based mission to the sun. Now this is going to be about 15 lakh kilometers away from the earth. It's going to stand there because of the pull of both these celestial bodies, the sun and the earth. This particular L1, the Lagrange Point 1, is that particular area, Varghese, where the repulsion and the pulling of the gravity of both these celestial bodies, the earth and the sun, is so much and it's so weird that your probe just sticks around there. It just stays there. And from there, Aditya-L1, our observatory deck, is going to have an absolute clear view of the sun, and it is going to study the sun right from there. So right after Chandrayaan 3, Aditya-L1. I mean, people are talking about why is it important to study the sun in the first place?
Well, the sun is very important because on many levels, we are talking about an era when you have this communication, satellites and electronics out there that has the potential to be fried up if there is a solar storm. Plus, there are a lot of things about the sun which we are not clear of right now. You require to have more data. It is not only us who are studying the sun. Across all the space agencies that are in the forefront are trying to understand its chronosphere. They are trying to understand the sunspots. It's trying to understand how the magnetic field works on the sun, whether there is a polar shift or not. All those aspects are being looked when it comes to the sun. So one of the biggest things that we've been looking at when it comes to the sun is that we believe, that hydrogen atoms are fused to create helium, and that is what we call as the fusion reaction, because of which we are having the energy coming out from the sun. How much of that is actually left in the sun is something that a lot of speculations have been going on. Though roughly people say that there's 7 billion years more life left in the sun. So all these speculations are going on one side, and yet exactly we know very little, but we tend to speculate a lot about the sun. And Kabir, you know why it's very difficult to study the sun, right? I mean, I don't need to tell you about it.
I mean, on Earth you can't look at the sun for bare seconds.
So one of the things about is that there are very few missions when it comes to studying the sun, and especially trying to understand its upper atmosphere, the temperature differences in its upper atmosphere.
Right.
And whenever there's a sunspot, also studies have been carried out. But mostly when you have an observatory like the Aditya-L1 over there, I think it just shows that everybody, I mean, one of the fact remains is that ISRO has come of age. It is now interplanetary, it's a intersolar system kind of an agency trying to study the heavenly bodies as well. So from the moon to the sun, I think it's a big leap.
Right.
But at the same time, it's going to give us a lot of data.
Absolutely. Let's take a look at how the headlines are shaping this particular story. After the moon, India will shoot for the sun on the 2nd of September. Now, just to give the viewers some sort of concrete information as to what is on the Aditya-L1, Varghese, where is it going, and why do we really need to study the sun? It's going to take 4 months to reach the destination. ISRO's workhorse, the PSLV C-57, will launch India's first sun mission, Aditya-L1 spacecraft, at 11:50 a.m. on Saturday from Sriharikota Spaceport. So those of you wondering where to catch it, Saturday 11:50 a.m. is when the launch is going to take place. Do join in on News9 for the latest developments on that. Aditya-L1 will take 4 months to travel to Lagrange Point 1, which is between the sun and earth, about 1.5 million kilometers or 15 lakh kilometers from the earth. Now, from this L1 point, the spacecraft will provide remote observations of solar corona and in situ observations of the solar wind. So essentially space weather, Varghese. That is what scientists want to try and understand. The space weather, how does these solar flares affect space weather, communication?
And one more aspect is like
it is the closest star to Earth.
Yes, and also we have seen, you see, there has been this speculation that intense space weather tends to be eating through Earth's atmosphere at the same time, and also they've been talking about how it could, how Earth's magnetic field tends to keep these solar flares away, but how much of it has been actually falling on the Earth and how it is working on. These are some of those aspects of those studies that's been carried by that is going to be carried not by us alone, but by other space agencies as well.
So the need to study the sun, Why is there a need to study the sun? Well, for those of you who are joining us and have more scientific acumen than the both of us sitting here in the studio, do get down in the comment sections and help us understand why you think there is a need to understand this phenomenon, to understand the sun closely. For me, I believe the next star after the sun is about 4.5 light years away. So that's like sending a probe which is going to take more than a decade just to reach that star. So sun is closer. You're going to take 4 months to reach the sun, and it's the closest star, so you understand what the star can do. But what are these Lagrange points? Now there are 5 locations around a planet's orbit. Okay, there are 5 locations around a planet's orbit where the gravitational forces and the orbital motion of the spacecraft, the sun and the planet, interact to create a stable location from which to make observations. And this is the same goes for the sun, which is holding the solar system together with each and every planet. So with each and every planet, there are 5 Lagrange points. The Earth is going to go to its Lagrange point vis-a-vis in context of the sun at point number 1. Now the Aditya-L1 mission is the first space-based observatory class Indian solar mission. The spacecraft is headed for the halo orbit around the L1 point because a satellite placed therein has a major advantage of continuously viewing the sun without any occultation or eclipse. This will provide a greater advantage of observing the solar activities continuously. Now there are 7 instruments, just like the Pragyan rover, just like the Vikram lander. There are 7 payloads on this. I asked a question to the scientist who was with us on the show as to, according to you, which is the most important one, and then I had to rephrase it because he said everything is important. And I had to rephrase it and say, ask him, which according to you intrigues you the most, to which his answer was, well, of course, he was talking about the solar wind particle experimentation, the ASPEX. But just to name these 7 science payloads, the visible emission line coronagraph studies solar corona and dynamics of the coronal mass ejections, which is the outer periphery, if I'm not wrong, of the sun. And we just had those visuals of the sun as well. You can see the outer ring. That's exactly what this is going to study. The solar ultraviolet imaging telescope, the images which images the solar photosphere and chromosphere in the near ultraviolet and also measures the solar irradiance variations in the near UV. Now you also have the solar low energy X-ray spectrometer, which is also called the SOLEX-S, the high energy L1 orbiting X-ray spectrometer, which are going to study the X-ray flares from the sun over a wide X-ray energy range. And then in the end, you also have the magnetometer, which is capable of measuring interplanetary magnetic fields at Lagrange Point 1. So this is why India wants to take a closer look at the sun. And of course, Varghese, we already are sitting on that high table now in terms of space research. So why not shoot for the stars?
In fact, we are shooting for the stars, and probably after this, there were talks about Shukrayaan, but I would be really interested because the only country that was able to land on Venus and get the brief data it got was the USSR, which had its Venera probes. So I'm looking forward to that itself. But yeah, this is going to be one of the biggest achievements on the part of ISRO when it comes to the study of the sun. And I think let's wait and watch what surprises they could actually be getting.
Well, absolutely. So September 2nd, do stay on.
It's going to be launched on
catch the launching live at News9, and of course the ISRO handles as well. 11:50 a.m. on Saturday, ladies and gentlemen. Aditya-L1 makes its way towards Lagrange Point 1.